I'm just out here playing. You guys have gotten to finally see the 6-pill is powered off of 2 of these switchers, and how we have 0 voltage drop with the 130 amp worth of draw on 2 of these. I don't have any video of it, but I've tested these multiple units tied together, and on 220 volts, that's a 200 amp supply. Now, I watched this guy on Facebook make the prettiest iron core 400 amp power supply I think I've ever seen. And I thought, wow, that's neat. Beautiful iron core made with the old iron transformers that come out of the APC battery backups. I thought, man, that thing sure weighs a ton, but it makes good amps, right? I thought, man, I wonder what that would take to make a 400 amp supply with these. It's 10 pounds, and in theory, that's enough amperage to run a 16 pill. 100, 200, 300, 400. This is in an oversized 2x4 cabinet. It's pretty cool. I was like, wow, look at that. Now, if we wanted to, we could throw another module in here like so, and throw another module in here like so, and put the fan on the outside. In theory, that's now a 600 amp module. The reason we can go so small is because of the switchers and the way we turn them on. We don't have to have a contactor. Internally, they have their own on-off switch, right? So we're talking 11, 12 pounds worth of weight for a 600 amp module, or 600 amp power supply. Check it out. So 15.2 pounds. Of course, then we put the lid on it. Of course, we'd have to block this off and put the fan in the back, but in theory, it's possible. I think this cabinet would comfortably hold 4 of these. And even if we underrate it and say it's a 350 amp power supply, I was trying to explain, I don't think people quite get it yet. Their minds aren't wrapped around what we're doing here yet. Once again, this is old technology. These cabinets are old, or the switch modules are old. To me, it's not all that. I mean, it's all that, but it's not really that big of a deal. So if I was to take, let's say, a 16 pill enclosure now, so we'll say 1, 2, 3, 4, 5, 6. Let's grab some more. Seven. Stacking them this way, 700 amp supply. Slide them in the middle. We don't have to provide space in between for cooling because that's not where the fans are at. We can literally squish these together as tight as we can get them. And I think if we were to trim these edges of the cabinet down, we could probably get 8 of them in here, edge to edge. So we'll say 8. 1, 2, 3, 4, 5, 6, 7. We'll say 8. Yeah, it'll fit. So if we were to trim this edge down and trim this edge down, we'd be able to get 8 to fit in there very comfortably. And then we'll say, if we wanted to, put another module here. That's 9. and put another module here. So it'll be 10. In theory, in a 16 pill enclosure, we could put 1,000 amps worth of switchers. There's so many different things we can do with these. Like we can float these cabinets and tie them together, so we could build out of this, you know, 2450. So have 100 amps at 50 with 4 modules. And then 1, 2, 3, 4, so 200 amps at 50 volts, which would be awesome. You'd be able to run almost any LDMOS 50 volt component. Or you can do, if you float them, what I mean by float them is you lift the board out and you make it so it doesn't contact the cabinet. Remove one screw and put a washer in it. And then you can stack them. So 12, 24, so on, up to 48. We stack another one on. So it'll be 50, 60 to 60 volts right here with these 4 little modules. Spot on the money. We could dial it up. That's 100 amps at 60 volts. So that means the newer LDMOS transistors, which everybody's struggling to have a power supply to run them, here's our answer. Another way to look at it is 15 volts a piece. That's 30 volts. That's 60 volts. So this is about 80, 90 amps at 60 volts. 62 volts if we wanted to crank each supply to, let's say, 15.5. So that would be 31, 62 volts. Right on the money what the new LDMOS transistors want. Food for thought. There's a lot of different ways we can go for this. Me personally, bought these 10 because I want to build a different 1,000 amp power supply. Underneath my workbench, I have a cube, a very, very large cube that requires, well, it's got 10 Meanwell RSP 1500-15s in it at $300 a piece, so $3,000 worth of modules. And I can conservatively say that that unit puts out about 980 amps versus 20, 40, 60, 80, roughly $200 worth of modules. So, I don't know. I mean, if a guy wanted to, he could probably go out and get on Amazon or Alibaba and buy the C13 adapter plug, which saves you from having to solder directly to the pins. Allow you to plug right into the back of the thing. By shorting this jumper and the fourth jumper over together with a little micro toggle, instead of having to have all these big contactors, which is more expense, or having multiple switches to turn on the banks, which is even more expense, it just gets easier. The only thing that we're going to have that's going to be expensive is going to be the breaker that you're going to put at the back. Not a fuse, because remember that runs out at 20 amps. The breaker, you got 2 of them. Something like these curling breakers. Everybody's familiar with these. Yep. Just an idea. Just an idea. I want to build myself a 1,000 amp power supply. How about we try doing that? Starting to wonder if this was a good idea or a bad idea to do this publicly the way I've done it. Oh, all right. Well, let's start here. So, this is my fugly beat down carbon pile I've had for years. I've killed 3 or 4 of them at this point. You know, I think I'm safe. I think I could take I should raffle this off. It's like the most abused carbon pile, battery tester in history. This thing is pretty beat down. I've caught it on fire where I've had flames shooting up out of it like this high on video. All right, so we're continuing on with the cheap power supplies. And they actually were very expensive when they were produced at $300 a unit. Switchers that are now bulk being dumped into the environment for $20. We have to test. I have to have a proof of concept, okay? And the proof of concept is I got to chain a bunch of them together, and then we got to stand on them. Like, we got to put some pressure on them, and we got to see what's going to happen. So this is the proof of concept video. I'm going to build a very rough power supply. Okay, I'm not going to be really rough because I don't build anything rough, but I wouldn't want to sell this to anybody because the way I'm going to put it together, I'm just trying to prove a point, and I'm underneath the gun for time. I don't have any more time that I can dedicate to this. I'm running out of time. I got to get back to taking care of people that have sent their equipment in. And see, this is only the first stage of this. Like I said, I've dropped hints, and I'm going to drop you another one. I literally went out and bought 2 of every watt class there is, and I've figured out how to hack every single one of them. These modules that we're talking about, the Dps-1200, okay, SBs, were the easiest that I knew that I could give to everybody for the home gamers. There is a whole lot more cool shit coming, but I got to come back to that in about a month. So I got to bang this out here in just like a day or so. Literally like a day. But it dawned on me that this little guy, either I could go buy 3 more of these and burn them all up, but then I seen that China Freight sold something new. Now the only reason this thing stayed alive is because I put this big ass fan on the back, and it screams a ton of air through it. All right. The biggest drawback to these are the shitty clips. And these are, I mean, let's face it, these have been hot. Okay. I mean, hot. Okay. I don't really trust this pile. I just don't. So, fresh from China Freight, I bought this little guy. A little scooching bigger cable, way better clips, like solid metal. But this is the El Special Presidential Professional 1000 amp pile. Carbon pile load tester, 6, 12, 24 volt. Batteries, alternators, regulators, and starters. I'm not going to lie, my friend Lindsay that works over at Harbor Freight, she used to work at Ace, now she works at Harbor Freight. I went over there and I walked up to the counter with this, the only one they had in the store, by the way. And I said, I will take this. She goes, oh, it's good to see us. It's good to see you too. I said, I want the extended warranty. She goes, why? I said, because I'm going to set this bitch on fire. And she just looked at me and she goes, you crazy? I said, yeah, I am. Remember, it says it in the intro. What I can't help but notice they've modified this just a wee little bit is we have a fan that is pulling air out. We have a fan that is pulling air in. So we've got a pressurized enclosure now. I think that's good. So this is going to serve as our baseline. Okay. So now, let's give ourselves a little bit of charge up time here. Oh, all right, so we're maxed out. We're at 15 volts. Let's put a hurting on this baby. Now I know my bench supply can do 6 to 800 amps for a relatively decent amount of time. Let me adjust this up a little bit more. We'll say 15.5, give or take. We're on the stop peg here. So let me come around. Oh, it's like butter. The other one's like trying to twist sandpaper. Okay, so there's 30, 40, 50. There's 1,000 in the corner. All right. All right. I weren't watching the numbers at all. I wasn't even paying attention. What caught my eye was this wire physically went, but we just put about a 1200 amp load on this, like no big deal. So let's see what happens here. Okay, so that's a 1,000 amp load. I'm over here, 11 volts, 11.5 at 1,000 amps. All right, all right, all right, all right. Oh, it's starting to stink a little bit. Oh yeah, got a little bit of heat. Like a kid with a new toy here. This is the meter I want to see max out. Here we go. Seven, 8, 9,000. Quits reading at 1,000. Look at that. Oh, I'm happy now. Boys and girls, this makes me happy. Okay, so yeah, the little LTOs are like, ah. Okay. So let's watch this is our amp gauge. Let's take a look at our volt gauge over here. So 1,000 amps at about 12 volts, 12 point, there, we just dropped under 12 on the digital meter. So this meter is off a little bit, but we've proven that the bench can pull 1,000 amps. So here, let's watch the volt gauge again over here. Oh, it's starting to stink now. Stinking good. Oh man, this knob is spring loaded. So there's 1,000 amps at 12 volts. We achieved it. So now, let's get all 3 of these in the window. Let's give it a minute for our batteries to kind of recuperate from what we're doing to it. Let's watch our volt amp gauge over there in a corner. So there's 400, 6, 8, 1,000. So it's relatively close. It's within a couple tenths. All right. Don't touch the power wires, BBI. They're friggin' hot. Oh man, oh it stinks. Oh, it stinks. That's a lot of energy to get rid of. That's a lot of energy, man. It took it like a champ. Yeah, wire's 183 degrees. Terminal lugs, of course they don't solder anything, 185. And going into the pile's 186. And that one is 178. Okay, let's burst this up and let's see what it maxes out at. So the only gauge we've got is that one there, and if I remember correctly, when I built this thing, the amp gauge on this is only like 500 or 600 amps, the shunt, so let's see what happens. Whoa, 1600 amps, boys and girls. I just burst it and I wasn't looking at it quickly enough. I seen 1670 something. So I'm gonna have to go back and look at that. Watch the leads as I do that. Did you see this cable jerk? That's beautiful. All right, so 1760 is what I saw on that. 1,760 amps, and that kept it at, well, below 11 volts, or above 11 volts, so I'm impressed. Okay, this just serves as our baseline. So let me let all this cool down, get this put away. I'm tickled with this. Hold on. Hold on. Good enough. There, that'll make it do 2,000 amps just by doing that one thing, right? All right, let me reset. We'll be back. So as I'm putting this together today, it dawned on me I wasn't going to be able to put all the fancy shit in here I wanted to put in here. And then I had to remind myself that this is just a proof of concept. But then again, for me, proof of concept is usually where somebody else would say finished. Okay. This is incredibly rough to me in my eyes, and I already see massive room for improvement. There's quite a few things here I'd change, and we're going to go over that, but this is a pretty good general idea of how you should go about doing this. So let's do this. Okay. Enough is said right here in the title. Will it do it? I don't know. Is it going to burst into flames? I don't know. I haven't plugged it in yet. But we're going to find out. Let's start on the AC side. First off, I don't have big enough power wire. That's my biggest complaint. I should have 4.3. Instead, I've got 6.4. This will work. Like, on paper, the 60 something amps this is going to draw, 66 amps. According to the data tag on the side of the module, on 220 volts it pulls 6.6 amps. So I need to provide it 66 amps. And I'd like to have 4.3 attached to this, just me personally, but we're at 6.3. Just from what I had laying around here offhand, these are dual 30 amp breakers, you know, this kind of thing. So we've got it breakered at 30 amp per leg. So 30 here and then an additional 30 over here for each one of the 110 leads. The C13 plugs are so cheap that if you guys don't use them, I'm gonna friggin' make fun of you on Facebook. I'm serious. You can buy a lot of 10 of these for I think $5 or less. If you buy them on Alibaba, they're like 35 or 40 cents each or cheaper. And that's for the C13 female connectors that actually plug right into the back of the power supply modules themselves. These things. If you are too cheap to buy these modules, these plugs, you probably shouldn't be building with these things. I'm just saying, this is that one little detail makes it so much safer. Now the first one of these I built with, I didn't put the plug in it because I didn't know what I had yet. As soon as I was able to get some testing out of the way, we spent a little bit of money. This is 14 gauge wire. I wouldn't even need this. You technically only need about 16. So this was brutal, but this is 14 gauge stranded. Number 6 wire coming in. 6 gauge, pardon me. So in theory, they say that I can pull continuous 50 amps on this wire. I'm like, okay, we'll see. We're gonna pull more through it than that. I'm just saying this is a little bit small. Let's flip it around. Let's go to the DC side. Okay, so this is 1/0 gauge cable, welding cable. Did that for heat reasons because I learned yesterday with playing with the 1000 amp supply that the 1000 amp carbon pile, that the leads get a little warm. So this is 8 gauge wire coming off of each module, and how I have this broke out is, of course, this top wire, which is red, that is part of the on circuit. There's a black wire down in here. Tie those two together, it turns on. And the white wire is what does the load sharing, which I can't wait to see how well that works, or if it even works the way I think it does. You know, one unit might just turn on and that's the only one that's got an LED on. Or one unit might turn on down here, and as the load comes up, it progressively kicks on the units. I don't know. We're going to find out together, you and me, right here in this video. You'll find that I do the same thing that I did in the 300 amp power supply build I did, which is inside the exact same cabinet, believe it or not. Where I play on the principle to keep the load even across all the supplies. I do usually a big butterfly pattern like this. And the reason I do that is because this wire here goes to this module, where this ground wire here goes to this module. So if we were to take and straighten this whole mess out electrically, as far as each one of the modules is concerned, they're all the same distance from positive and negative from the load. So this wire here goes to this wire here. The red wire, which you can't see, which is down here, goes to this one here. So the longest and the shortest are opposite of each other. That way we pull evenly across all the power supplies. We have the same thing going on with the 220 volt lead. If we straighten this all out, the module that's the closest over here, okay, versus the module that's over here, it's the same principle. That way everybody gets to drink from the same straw and the same level. We used heavy duty, really thick fiberglass back here because of the heat. Those stainless steel bolts that are back there are going to get hot as sin today. The reason they're going to get so hot is because the clamps that are on the load pile suck. They have very little spring retention to them. They have lots of surface area, but very little spring retention to them. So there's not a lot of pressure, and we're going to spread that out over a very small area, and we're going to put a shit ton of current through it today. I hope. Who knows? This thing might catch on fire and blow up as soon as we plug it in. We're going to find out. We're going to find out. So, let's plug it in. Let's see what happens. Let's take the one little switch for all mankind. Make sure it's off. And let's go down here. Power supply is plugged in. Power supply's on. It's that quiet. I think the carbon pile is going to put off more noise than this thing is. Power supply's on. I can see green lights bouncing around on the back over here. So, power supply off. Okay, let's test this thing. I want to beat it up a little bit. Okay, I think I got this framed well enough. It's really important to me that I got all the wires showing. Because the first thing some hater is going to do is they're going to jump out there and, oh, I faked it. Well, how do you know I faked it? Well, because you couldn't see on the video where the wire to the voltmeter disappeared. You couldn't see it. It wasn't in frame. I'm telling you, I've heard. Let's zero that out. So we're at 0. Now this thing reads to a 1000 amp max. Okay. This is our AC voltage. This is our DC voltage. Our DC voltage is hooked up to the 2 1/8 gauge cables. This voltmeter on this pile, I am not going to put any faith in it as far as its voltage reading. These clips here suck. And as we bring the load on, the voltage inside the pile is going to start to drop. So the only thing we need to keep an eye on is the amount of current flowing through the pile. Let me bring this a little bit closer for all of us to see. The voltage on the power supply. So let's turn the supply on, and the fans on the pile are going to kick in. Okay. 15.8, pull about ½ amp for the fans. Let's see what happens. The smoke's going to come pouring out of this thing, or it's going to work. There's 100 amps. There's 200 amps. 400 amps. 500 amps. Looking pretty good. 600 amps looking pretty good. 800 amps looking really good. 1000 amps. Well over 1000 amps. There we go. 900. 990. 14.8 volts. I'll take that. 14.8 volts with over 1000 amps worth of load. 1200 amps worth of load. You guys see the wire flexing? Well, let's make it do it violently. Oh, we got it to crowbar. Turn the unit off. Unit back on. All right, crowbar. See the wire flexing? But to get it to flex, I'm having to put well over 1000 amps on it. See what started popping. We got something to pop. Let's go find out what it was. I don't know what it was. I can't find it. I'll get it to show up again here. So right at 1000 amps, 14.6. Like I've told everybody, if I get 800 amps out of this thing, I am tickled to death. Okay, I see what's going on now. These terminals are getting hot. The fiberglass is getting hot from the stainless steel nuts with me standing on it like I am, because these things have got like that much spring tension to them. Oh yeah, these wire leads are smoking over here. That's funny to me. I think that's great. Remember, we don't have any air on anything either. Just internal fans, right? So let's go over here and let's take a look at this. Now that we proved Proved that we're just beating the shit out of shit for shit reasons. It's a little bit closer for you all on the cell phones to be able to see what the heck's going on with the amp meter. Remember, this is a 1000 amp max. So it's already over. It's 800, 900, 1000. Wow, them terminals are really smoking. The positive terminals, hotter, the ground terminals, hotter than hell. Look at this. All right. If you insist. All right. Hold on, y'all. Let's get a measurement on this. 339 degrees. How hot's our power wire? Our pile wire, let's say. Oh, the wire's only almost 200 degrees. The post that's shiny, yeah, it's 300 and something here. 400 something on the inside, so yeah. But here the wire's cool. It's only 123 degrees. That one's 120. So, okay, let me put some air on things and let me let everything cool down for a minute. Okay, now we got fans kind of blowing air on everything. Giving it a good 10-15 minutes for everything to cool off. All right, now I want to do some data measurements. So this is amps coming just through the one leg of the 120, or the 220 I mean. So we're measuring just one side. Let's dial the amps up. So there's 200 amp draw, 400 amp draw, 600 amp draw, 800 amp draw, 1000 amp draw. Okay, so we weren't too far off. We're only 10 amps off on our draw, on our math, and that makes sense because a little bit too small a wire. And okay, 76 amps for my personal knowledge. 14.82 1000 amp draw. It's not too bad. It's not. The line voltage isn't dipping down too bad. Look at that. 1000 amp draw. So we're losing 4 volts on the line voltage. Man, I'm impressed. This thing works. That's 1400-ish amps. When I turned the knob to the stop peg, we figured this out yesterday when I was doing the proof of concept. So we put 1400 amps on this thing. It's pulling. I mean, what's our voltage drop when we're maxed out? $13 volts. Shit. Are you kidding me? 13 volts at 1400 amps. Man, I'm sold. Oh, that's great. Hello, 1 2 1 2 1 2 1 2. Hello, 1 2 1 2 1 2 1 2. Hello, 1 2 1 2 1 2 1 2. Hello, 1 2 1 2 1 2 1 2. I'm pretending like we're modulating. Hello, 1 2 1 2. So we can get kind of an idea of what a real world what we're looking at here. That makes sense? Now if I bang this too hard, it goes into crowbar. And that thing is as steady as a rock. And I love that. The crowbar protection's working. Hello, 1, 2, 1, 2, 1, 2. But still, at 800 amps, we're at 15 volts. Win. Win. Okay, so here's an interesting, we'll say causality, okay? A very interesting cause, and I don't want it, I'm just gonna put this out there because I don't want anybody to be thrown off at what they're seeing here. I had one guy call me this morning already, and he's like, man, I got my splies in and I got them put together, and when I turn them on and I got them in the load share, and then I turn them on and then they all shut off but one. I'm like, yes. And it dawns on me I haven't pointed that out. Of course, I didn't really see the phenomenon until I built this big bastard. So right through here is all the LEDs that indicate the power supply is in functional use, right? So here to help us out even more, let me show you this. This is important to see, I think. So watch. Turn on all, and then they're going to go into load share mode here in a second. Watch what happens. Bloop. All but this one down here shut off. The power supply is on and working just fine. It's in load share, so this is the control. Look, the term that the electronic industry has adopted, and this is not my term, this is the term that is universally accepted and adopted, is this would be the master power supply, and the rest of these are slaved to it. The term I like to use is controlled. This is the control supply, okay, and the rest are regulated to it. So this is the master supply, and the rest are, well, tied to it. Just keep that in mind as you're going along. Don't freak out. The first time you power these up, they're going to go through a little self-diagnostic mode when they're all chained together like this. The fans will go into turbo drive mode for like 4 or 5 seconds, and then it's just going to go, and they're going to slowly ramp down. When they hit the bottom of the line, just go ahead and shut them off, turn them back on, and you'll never have to deal with that again. But be aware of this phenomenon of all green lights. They talk to each other for a second, and bloop. This is the control unit. Okay, I have not tried it yet, so I can't tell you if that stays true without the load share lines tied together. I haven't broken these out yet. I'm planning on doing that later today. But for right now, I think we got our proof of concept done. I want to put a lid on it, and I want to wrap this up. So I sat down and I did the math last night. I have roughly $900 worth of parts inside this one supply. Fancy case, pretty acrylic covers with smoked custom logo, water flow jet freaking fan guard, all the wire connectors, breakers, contactors, power cord, everything's about 900-ish, just in parts. After my time to build it, the price for something like this would be about $1,700, $1,800, $1,900, somewhere in there. Honestly, I got no use for this. I just built it as a proof of concept. So I don't know, if the right cat called me up and offered me enough money, I'd probably get rid of it in a New York second, and I'd just go on and build me another one. Here's the thing, yo. Because we were able to shrink the cabinet, shrink the number of modules, shrink the hardware, and so on, the end result is right now, roughly 1,000 amp regulated supply in the market is about $2,400. Okay, so we were able to cut the cost $2,400 to $2,600. So we were able to cut $1,000 off of the power supply cost and cut its size by 2/3. So yeah, made it smaller, made it cheaper, and made it better. I think that's awesome. Well, like so many wonderful things that I've been lucky enough to be involved with or get to build in my career, the time has come for me to put a lid on it. And all that beautiful craftsmanship just goes inside and sits, and no one can see it. I have my acrylics guy working on making me a clear lid for some of these future projects, and I might switch this out to a clear lid. But for the time being, I want you guys to be able to hear how quiet this thing actually is. That is the power supply on and running. And this super low profile fan is making more noise than all the switchers inside this cabinet combined. This has been a fun little experiment for me. This is my proof of concept for you all. As in what it can do, how to tie them together, and is it possible? And the answers to all of those questions are yes, you can, and it totally is. Gentlemen, my name is BBI. I want to give a big shout out to Penta Labs, Excess Power, Mechland, Bird, Coaxial Dynamics, all of my Patreon supporters, and especially every single one of you. And on that note, I'll see you guys. Click, click, click.